Assalamu alaikum everyone. My name is Jahidul Islam Siam and it is my honor to stand before you today as the first speaker of our group presentation. Today our team will presenting on the topic basic behavior of RLC circuit in electronic device. Before we dive in, allow me to introduce the brilliant mind who have contributed to this presentation. Sajid, who will be covering resistor behavior. Tuhid, who will discussing about inductor behavior. Shubha, who will be presenting capacitor behavior. Zarin, who will be elaborating on combined RLC behavior. Now let's jump into my topic. An RLC circuit is formed by combining three basic components: resistor, inductor, and capacitor. These are the building block of modern electronics. When connected together, they create circuit that can filter signal, store energy, and even generate acceleration. In daily life, RLC circuits are used in radios, television, and mobile phone. They help select frequencies and control energy flow.
Hi, I'm Tanin Shazib and my ID is 252-15616. And today's presentation is about basic behaviors of RLC circuit in electronic devices. And I'm going to cover the part of resistors. Even though it's one of the simplest component, it plays a really crucial role. A resistor limits the flow of current and turns some of the energy into heat. In an RLC circuit, it's really key because it controls how quick the circuit oscillates die out. For instance, in audio system, the resistance keeps signals from getting too strong or distorted. And in power supply, they help limit current and protect the circuits. In fact, in the equation, we represent the resistors with R. The bigger the resistance, the faster those oscillations fade away. So the resistance is all about energy loss, stability, and keeping the circuit safe. Without it, things would just get too unstable and risky. Thank you.
Assalamu alaikum. I'm MD Tawhidul Rahman Tawhid. My topic is inductor behavior. An inductor stores energy in a form of a magnetic field. It resists certain changes in axial current. Inductors cause the current to lag behind the voltage. Inductors are used in tuning circuits such as radios, where they can select a specific resistance for them. They also used in transformers and power supplies to store and transfer energy in the circuit. The inductor represented by L, and it mainly depends on the behavior of frequency. So inductor contributes on energy storage, frequency control, and smooth current flow. Thank you, everyone.
Thank you, Tohid, for inviting me. Hello, I am Shubha Burman. Now I discuss about the capacitor. A capacitor stores energy in the form of an electric field. It resists changes in voltage. In RLC circuits, capacitors cause the voltage to lag behind the current. A capacitor is made of two plates separated by an insulating material. When voltage is applied, it stores charge. If the voltage changes suddenly, the capacitor opposes that change. Capacitors are widely used in filters, timers, and oscillators. For example, in mobile phones, capacitor helps filter unwanted signals. In camera, they store energy for the flash. In the circuit equation, the capacitor is represented by C. At low frequency, capacitors resist strongly, but at high frequency, they allow signals to pass. So the capacitor provides energy storage, timing, and signal shapings. It is essential for controlling voltage behavior in electrical device.
Assalamu alaikum everyone. I am Jarin Tasnim, ID 252-15870. Finally, let's see what happens when we combine resistor, inductor and capacitor together in one circuit. The RLC circuit can oscillate at a natural frequency called resonance. At resonance, energy continuously transfers between the inductor and capacitor. The resistor controls how quickly these oscillations fade. This resonance property is extremely useful. It allows circuits to select specific frequencies, which is why RLC circuits are used in radios, televisions, and communication systems. For example, when we tune a radio to a station, the RLC circuit inside selects that exact frequency while ignoring others. In medical devices, RLC circuit help filter signals for accurate readings. In summary, the resistor provides stability and damping. The inductor stores energy in a magnetic field. The capacitor stores energy in an electric field. Together, they balance energy storage, energy loss, and frequency control. In conclusion, RLC circuits are the backbone of modern electronics. They make communication, filtering, and energy control possible. Thank you for watching our presentation.